The concept of time travel has captivated the human imagination for centuries. It is a staple of science fiction and fantasy. We are fascinated by the idea of journeying through time. Imagine witnessing historical events firsthand or glimpsing the future. The possibilities seem endless. But is time travel merely a product of our imagination, or could it be a scientific reality? Time travel challenges our understanding of the universe. It forces us to confront profound questions about the nature of time itself. Is time a river that flows in one direction, or could it be a dimension we can navigate? These are questions that scientists and philosophers have grappled with for generations. For centuries, humans perceived time as a linear and absolute phenomenon, much like a river flowing inexorably downstream. Early civilizations developed clocks and calendars to measure time's passage. These tools reinforced the notion that time was a constant, universal rhythm governing our lives. This classical view of time, however, would undergo a profound transformation in the early 20th century. The invention of the clock was a pivotal moment in human history. It allowed us to synchronize our activities. It gave us the illusion of control over time. However, this perception of time as a rigid, inflexible entity would not last. The seeds of a revolution were sown with the work of a young physicist named Albert Einstein. In the early 20th century, Albert Einstein revolutionized our understanding of time with his theory of relativity. Einstein proposed that time is not absolute, as previously believed, but is relative to the observer's frame of reference. This means that time can pass at different rates for observers who are moving relative to one another. One of the most startling predictions of Einstein's theory is time dilation. Time dilation states that time slows down for objects in motion. The faster an object moves, the slower time passes for it relative to a stationary observer. This concept, once considered outlandish, has been experimentally verified numerous times. Imagine two identical clocks, one at rest and the other moving at a high speed. According to Einstein's theory, the clock in motion will tick slower than the clock at rest. This difference in timekeeping, known as time dilation, becomes more pronounced as the speed of the moving clock approaches the speed of light. Time dilation is not merely a theoretical concept, it has real-world implications. Consider the Global Positioning System, or GPS. GPS satellites orbiting Earth at high speeds experience time dilation. Their internal clocks run slightly slower than clocks on Earth's surface. To maintain accuracy, GPS systems must account for this time difference. Without relativistic corrections, GPS navigation would be wildly inaccurate. Section 5. Evidence of time dilation. The evidence for time dilation is compelling. Experiments with atomic clocks have demonstrated that clocks flown around the world in jet aircraft tick slightly slower than synchronized clocks on the ground. These findings, consistent with Einstein's predictions, provide tangible proof that time is not the constant we once believed it to be. Perhaps the most dramatic example of time dilation involves astronaut Scott Kelly. Kelly spent a year aboard the International Space Station, orbiting Earth at high speed. Upon his return, scientists discovered that Scott had aged slightly less than his identical twin brother Mark, who had remained on Earth. This real-world example of time travel, albeit on a small scale, underscores the profound implications of Einstein's theory. Section 6. Time travel to the future. A real possibility. Time dilation, while subtle at everyday speeds, raises the tantalizing possibility of time travel to the future. If we could travel at speeds approaching the speed of light, time would slow down significantly for us relative to those on Earth. A journey that might seem like years to us could amount to decades or even centuries back home. However, achieving such incredible speeds presents formidable technological challenges. The energy required to accelerate a spacecraft to near-light speed is immense, far beyond our current capabilities. Moreover, the stresses on a spacecraft and its occupants at such speeds would be enormous. Despite these hurdles, the concept of time travel to the future remains scientifically plausible. Section 7. Wormholes, shortcuts through space and time. While time dilation offers one avenue for potential time travel, another theoretical concept has captured the imagination of physicists and science fiction writers alike: wormholes. Wormholes are hypothetical tunnels through space-time that could connect distant points in space and time. Imagine a sheet of paper representing space-time. A wormhole would be like a shortcut tunnel through the paper, allowing travelers to bypass the vast distances between those points. While the existence of wormholes remains purely theoretical, their implications for time travel are profound. If we could create or manipulate wormholes, we might be able to travel not only through space but also through time. Section 8. The mysteries of time travel. The concept of time travel is fraught with paradoxes and unanswered questions. One of the most perplexing is the grandfather paradox. What would happen if a time traveler were to go back in time and prevent their own grandparents from meeting? Would the time traveler cease to exist? Or would the universe split into multiple timelines? These are just a few of the mind-boggling questions that arise when we contemplate the possibility of time travel. While we have made significant strides in understanding the nature of time, many mysteries remain. The quest to unravel these mysteries continues to drive scientific inquiry and fuel our imaginations. Section 9. Conclusion. The everlasting fascination of time travel. Time travel, once relegated to the realm of science fiction, is now a subject of serious scientific inquiry. Einstein's theory of relativity, with its predictions of time dilation and the warping of space-time, has opened up new avenues for exploring the possibilities of time travel. While technological hurdles remain, the concept of journeying through time continues to captivate our imagination. As we delve deeper into the mysteries of the cosmos, we may one day unlock the secrets of time travel. Until then, the allure of exploring the past and glimpsing the future will undoubtedly continue to inspire generations to come. Don't forget to subscribe to AI Adventures for more explorations into the wonders of science and technology.